please welcome CEO of Secret Network, Guy Zyskind.
Thank you very much.
Thank you.
Hey, everyone. Good to be here again. Always great to be in Prague. Let me see that this is working. Yep. This is the most important slide, for me at least, and I think for you today. But actually, before I start, how many here are developers? How many have seen, like, a Solidity line of code or a CosmWasm line of code? OK, half of the people. So I just want to set a baseline. So I've been in the intersection between privacy and blockchain for about a decade now. I'm very, very long OG. And the one thing that really frustrates me is how much privacy is misunderstood. So whenever you talk about privacy in blockchain, people always take it to this idea of private transactions. The idea that you can send money anonymously from one person to the other. And once you go there, you have this discussion, argument, whatever you want to call this. You have two camps. You have the cypherpunks who are saying, we should control our own data. Privacy is normal, as Zikesh very well puts it. And it's all OK. And then you have usually regulators, government saying, it's not OK. We need to be able to probe in. Because there may be money laundering, terrorist financing, and all those things. Now, that discussion is very important. I obviously have my own opinion. I'm probably closer to the cypherpunks in that grand scheme of things. But that is completely misleading. That is one niche, and that is not the important part when it comes to privacy. At the end of the day, privacy is an enabling technology. And we need to move away from a discussion about protecting data privacy to this idea that we need privacy as a basic building block in Web3 to actually build all kinds of use cases. So if you take randomness, for example, right? If you're doing a lottery application, an NFT mint, any kind of ZK game or any kind of game on chain, you usually need randomness. To create randomness, that randomness needs to be unpredictable. It only needs to be revealed at a specific given point in time. Now, no one cares. The regulators don't care. That randomness is not per se sensitive data. It just needs to be unpredictable, which is why it needs to be private. So the regulators don't care if that's private. The people don't care. It's not their sensitive data. It's not per se sensitive data. But that is an example why privacy is important, even if you don't care about this whole discussion about privacy is normal, privacy is not normal. Sealed bid auctions is another example. People don't really care. They don't consider their bids to be sensitive data. But it is well known that sealed bid auctions are way, way more efficient than normal auctions. So that's another example where privacy is an enabler, and it's beyond the usual discussion. And we kind of wanted to formalize that in Secret. And basically, we saw that a lot of applications that are basically how to use privacy to enable new use cases, we try to put that under like one umbrella. And we try to put it as something that developers can understand and interact with, not just on Secret, but outside of Secret. So obviously, our go-to target, and this is a Cosmos event, is the interchain. It's other IBC network. But we're putting a lot of thought about how to extend that to Ethereum. And you know what? Even how to extend that beyond blockchain in general, right? Like, even if you're building a tool or a wallet, you may be able to use things that live on Secret that are beneficial to you. But I'm not going to talk about all of these because I don't have time. I want to really focus on one. I want to focus on this idea called unstoppable wallets. That's like one class of application within this whole privacy as a service umbrella. And then we have, in 2 hours, our amazing 2 core devs, Lior and Eshel. They're going to do a workshop on the on-chain randomness part or secret VRF that I mentioned. But let's drill deep into unstoppable wallets. So what are unstoppable wallets? Let's start with something that predates unstoppable wallets, and that's MPC wallets. How many people here heard of MPC wallets? I actually expected to see everyone raise their hands and everyone to know what it is. So I'll give a very, very quick explanation. At the end of the day, wallets are just private keys. We have a private key, we sign a transaction, and that allows us to move assets from one chain to the other, one account to the other. But it's a single point of failure, right? You lose your private key, you lose access to your money. If someone gets access to your private key and steals it, you lose access to your money. And by the way, this is another example where the data privacy discussion is not important, right? Like, you don't care, and the regulator doesn't care to know your private key, and they shouldn't. You care about only you knowing your private key, because if someone else does it, then your money is gone. Now, MPC wallets are really multisig wallets. I'll stop here. How many people know what multisig wallets are? Okay, that's everyone. So MPC wallets, for all intents and purposes, are glorified multisig wallets. What do I mean by glorified? They are still like multisig wallets. They allow you to have like T out of N signing, so maybe like 5 out of 8 people need to sign a transaction in order to move an asset, in order to send a transaction. But they have all kinds of benefits. The main benefit that they have is that they are cross-chain. Multisigs, you gotta implement that for each chain separately, but MPC wallets, they are basically multisigs that at the end of the day produce a signature for a transaction that looks the same for any chain. So it's much easier to deploy on a wide variety of chains immediately. And the way, and if you don't know, MPC wallets are really basically winning the custody game. So companies like Fireblocks and Coinbase and others, they are basically deploying a system where a user or a group of users, like the left side here, could actually be like 5 out of 8 users, and then the right side is like a service provider. The users get a key or several keys, the service provider gets a key, and then through like MPC magic, which I won't get into here, you can basically sign transactions. The key part here is that you solve the problem of having a single point of failure, whether it's you because you're self-custodying your assets, or whether it is some centralized exchange that, like FTX, that can go out of business any day, and best of luck to you. But this is not good enough. This starts to feel more like a Web 2 solution for a Web 3 problem, right? You still have to trust the service provider quite a bit, because if that service provider goes offline, sure, they can't steal your money anymore. That's a big difference. But if they go offline, you lose access to your money. And it goes even beyond that, because you also need to trust them to, they're not open source, it's closed source. If you want all kinds of new features, you can develop them. You're going to have to wait through their development cycle. It's not composable with blockchain applications. There's a lot of limitations there. What you really want is you want to replace a service provider with something that we're more familiar with, like a blockchain. And that's basically exactly what we did with unstoppable wallets. We take the centralized party that holds one of the keys, and instead we put secret, the blockchain, in there. And now users can co-sign. Think about a secret here as this kind of like co-pilot, your always online wingman that is always there to help you sign transactions, but you can also program it. Because at the end of the day, secret runs on smart contracts, specifically on CosmWasm smart contracts, and you can program them to do anything. That's why this is not a one use case, but a building block. The problem with building this is that now you have to put inside CosmWasm, inside smart contracts, you have to put like really, really complicated cryptography. And if you've ever written a contract in your life, running cryptography inside something as constrained as a smart contract is not going to work. It's really slow. It's going to fill the entire blocks. It's going to take too much gas. It's going to cost too much. It won't work. And when we went to attack this like 6 months ago, we actually were like at an impasse. Like we went through all the state-of-the-art protocols, and we did the simulations, and none of them would run on chain. And so then we went and did probably one of this, at least at the time it seemed like very stupid, and we said, okay, you know what, let's roll around crypto, let's actually go deep into the cryptography and just build a protocol that can't work on chain. And it took, we thought it's going to take like 2 months, it took 6 months, but today we're basically releasing new research. This is going to be on ePrint like today or tomorrow. So if you like want all the gory details, you should read the paper. It has like security proofs, and we went through all the motions and the gross stuff just so that we can feel comfortable that it's secure. But the point is that we built an MPC wallet that runs on-chain inside of a COS and WASM smart contract with all the cryptography on-chain, and it's way, way faster than any other threshold ECDSA, which is basically the algorithm that you need, that you have there. It's like 2 or 3 orders of magnitude. We actually benchmarked it, and it's faster than doing something like an AMM swap. An AMM swap costs more gas than running this cryptography on-chain. And I promise, this is the most technical slide I have, but if you are interested in the details, know that as we developed this, we actually realized that we're able to get some nice properties that no other MPC wallet has. So one of them is robustness. Robustness basically says that even if you have, let's say, 10 signers, but one of them cheats, the protocol will still be able to recover from that and complete and produce like assigned transactions. It doesn't, anything that came before that, basically it had to stop and see who cheated, and then you had to restart without that party. In this case, it's fine. If you have like a small number of people who cheat, you just kick them off and complete the signing process in one go. And then the other one, which is actually even cooler, is fairness. Fairness in MPC protocols basically says that there's a computation. In this case, the computation is let's sign a transaction. And in the computation, either everyone gets the results, or, the question is, if there's fairness, then either no one gets the results or everyone gets the result. And it's actually well known that if you have too many cheating parties, you can't do that. You can't get fairness. But because we're leveraging a blockchain, we actually show that in our scheme, and this is the only scheme that can do this, the only MPC wallet scheme that can do this, you get fairness anyway. Okay, I'm going back up, less to the gory details. One thing I want people to pay attention for is that there's this whole craziness called account obstruction or smart contract wallets in Ethereum. It's less common in Cosmos, but account obstruction is really limited to Ethereum, to one chain. And unstoppable wallets, I'd say that they're equivalent, but they are immediately cross-chain. So you can use it, and you can immediately deploy it on any other chain, whether it's EVM or Cosmos or Solana or whatever. Okay, so I've said a lot that this is a building block and that unstoppable wallets are programmable. What does that mean? Let me give you 2 examples. So the most obvious example that you may be already thinking about when it comes to this use case is this idea of having a multisig wallet. Okay, that's by design, MPC wallets are multisig wallets. But now, because you have a smart contract component, basically these are the users, this is a smart contract, everything that's happening here. That component, you can program any policy that you want. So we made a very simple example to showcase this. The contract checks that there's enough signers. So let's say it's a 5 out of 8. It needs to check that at least 5 people are coming together to sign a transaction. And then it checks that there's a spending limit, and there's at most 1 ETH being spent, right? If it's more, then it blocks the transaction. And obviously, you can put whatever policies that you want. That's the idea of being programmable. This is just a simple example. Another use case, and this is, I think, completely counterintuitive. I mean, so far we talked a lot about custody, but this goes beyond that. In crypto in general, when we talk, we always talk about transacting in assets. You know, if I send someone secret, I send from my wallet to someone else's wallet secret. If I'm going on osmosis and I do a swap, I exchange my secret to Atom or vice versa. We are always talking about assets. But what if we could flip the equation and actually do a wallet exchange? What if we can just sell the wallets directly? And if you kind of want to understand why that's interesting, just so that you know, this happens today all the time with pen and paper. Like you have VCs who buy locked tokens, or maybe they buy a SAFT for a token that doesn't even exist yet, and then they basically do some over-the-counter agreement because they need the liquidity now, and they resell it to someone else. But here you can do that in a provably secure way, because you can actually have a contract where one party sells their private key, their wallet, to another party in a way that provably removes access from the selling party. That's the key point, because if you try to do it without this system, and I sell you my private key, well, now I have access and you have access. That's not useful. And if you want to take it really far, then you can think about something like Mt. Gox or FTX. There's a lot of people now sitting with claims. There are brokers that want to buy those claims. So you can even think about like an exchange, not like the ones that are popping up today, but an actual secure exchange where customers can maybe sell to get immediate liquidity, like with 20 cents on the dollar, their access to their claiming wallet, and then see at least some money today. And there are many other applications that you can do with this. I mean, we're not going to enumerate all of them. I don't think I can think of all the use cases. Our team cannot think of all the use cases. But one other use case that's interesting to me and that I like is this idea of like unruggable DAOs. So as I'm sure everyone knows, DAOs are this cool concept. You have token holders. They vote on all these decisions, how to use the budget, and none of it really matters because at the end of the day, you have 5 people controlling the treasury. That's not great. But what if we can use this mechanism to actually keep the DAO accountable? What if the DAO has also this unstoppable wallet contract where there are exact rules and spending limits on how they can use and actually exercise and use the treasury? They can't just take it away or do what they want. Number 2, what if we can tie governance mechanism? I know Jake talked about DAO before. So what if we can tie governance mechanisms such that votes are binding? So maybe there's like a big spending vote that the DAO votes on, and then we take the result from that contract, we plug that into this unstoppable wallet contract, and only then can the DAO actually be able to complete and sign a spending transaction according to what the community decided. And there are many more use cases like that. Hopefully, if you're a developer, you're going to think about that, and if you have ideas, talk to me. One more detail I want to mention, because I think this is separately interesting, even though it's a building block within what we developed. I glazed over and told you that we've put a lot of like deep cryptography into secret in the process of making this. This has been work that we've been doing for 6 months. And one of those key components is something called homomorphic encryption. Homomorphic encryption is basically the idea that you can encrypt data and then just run computations over that encrypted data. Now, there's this concept of fully homomorphic encryption, which says that you can run any computation over encrypted data. That is the holy grail. That is not what we've done. That is 1,000x harder to do and 1,000x more useful. But what we did is we put partially homomorphic encryption. So you can do some operations over encrypted data, but not all operations. But even that has a lot of use cases. And I don't think you can see in the slides the code. Can you see the code in the slides? OK. So the marked up version basically shows you in a Cosmos of a smart contract how you take two numbers, you encrypt them, and then you can basically add them together over the encrypted data. So you can do those kind of things, and that is really cool. And as far as I know, Secret is the only blockchain to have ever been able to pull this off in general, and hopefully people here would have ideas on how to use this. Like I said, I'm not going to talk about the Secret VRF and the on-chain randomness. That's another thing that's like new on Secret right now. It's on mainnet as of a few weeks ago. There's going to be a workshop at 3, as I mentioned. You should really go there because it would show you how easy it is for any dApp or chain or project. You don't have to be building on Secret, and how to utilize secure randomness in your application. And I think at this point, even though I'm a bit early, I would rather like open it for questions. There's a few take-home messages that people should take. Privacy is not just normal, it's also useful. Privacy as a service is really a way to opening up all this usefulness to other chains. And unstoppable wallets and Secret VRF are really, really cool building blocks. And we've put a lot of like deep cryptography into them and into Secret. And basically, you should now start thinking about how you can use all these cryptographic tools in Secret going forward. And with that, thank you very much. Happy to take questions.
Thank you very much. I'll take this. Thank you. So unfortunately, we don't have any questions. But again, if you do have, like maybe later on, you can grab Guy somewhere here around. And
I'm here the entire day, feel free.
all right. Thank you so much
Thank
once
you.
again. Thank you.